Next topic is criteria for spontaneous. Criteria. That means what? What is the necessary condition for a spontaneous reaction? Now I take some examples of spontaneous reaction. First example is H2O solid is converted into H2O liquid. This is what this reaction indicates what? Melting of ice. How can we say that an ice is converted into liquid? So H2O solid means what? Ice. Ice is converted into liquid. That is what? Melting of ice. That is spontaneous process. If you put that ice under room temperature or under room conditions, then ice is immediately converted into liquid. For that process, delta H is positive, delta S is positive. How can we say that? This is when solid is converted into liquid, automatically randomness increases. Then delta S will be positive. If solid is converted into liquid, it needs some energy. It needs some energy. That ice absorbs some energy from the atmosphere. Then only it can convert into liquid. So that delta H will be positive. I hope you understand. Next one, H2O liquid to H2O gas. H2O liquid to H2O gas. That means water is converted into water vapor. This is what? This reaction indicates what? Evaporation of water. That means when you suppose when you put a glass of water under a room temperature, what happen? After some time the level of the water decreases by gaining energy. That is also what? That is also what? Spontaneous process. For that spontaneous process, for that process, delta H is equal to positive. Delta S is also positive. Why delta H will be positive? Here, there liquid is liquid gains some energy. If energy or heat is needed, that means if energy or heat is absorbed in a reaction, that is what? Endothermic reaction. Here liquid is converted into gas, so that delta S will be positive. Next, 2H2 gas plus O2 gas gives rise to 2H2O. Here gases are converted into liquid. This is also spontaneous reaction, because when hydrogen and oxygen gases combines with each other in air, in atmosphere, after some time water will be formed, but after it takes more time. That is different thing, but that is what? Spontaneous reaction. Then what about the parameters of delta H and delta S for this reaction? Here gases are converted into liquid, automatically randomness decreases, delta S will be negative. When gas is converted into liquid, it liberates some energy. Nothing but exothermic reaction, so that delta H will be negative. All three reactions are spontaneous, but first two reactions, delta H, delta S positive, but the third reaction, delta H negative, delta S negative. So what is the important point from these three reactions? We can't say whether the reaction is spontaneous or not by using delta H and delta S. I repeat that point, listen carefully. We can't say the reaction that whether the reaction is spontaneous or not by using delta H and delta S. Because in some spontaneous reactions delta H value positive, in some spontaneous reactions delta H negative, like that delta S also. So we can't predict the reaction by using delta H and delta S, that whether the reaction is spontaneous or not. To explain the spontaneity of a reaction, Gibbs, his scientist, Gibbs proposed a new term is called Gibbs energy or free energy. Now we have to know what is Gibbs energy or what is free energy. See, the amount of energy is available to do useful work is called Gibbs energy. That means we have to do some work by using available energy. That energy is called Gibbs energy. One more definition is there. That is the difference between enthalpy, that means H, and product of temperature and entropy, that means T and S, is called Gibbs energy. Mathematically, we can write like this: Z is equal to H minus Ts. This expression can be obtained by using this statement. Here, Gibbs energy of a system also cannot be determined because all are state functions: internal energy, enthalpy, entropy, Gibbs energy, all are state functions. We cannot determine state functions theoretical, but change in state functions, that means change in enthalpy, entropy, change in internal energy, change in Gibbs energy can be determined experimentally. That is like this: delta G is equal to delta H minus S delta T minus T delta S. Delta G equal to delta H minus S delta T minus T delta S. For isothermal process, delta T equal to 0 because in isothermal process temperature is constant. Then delta G equal to delta H minus T delta S. Now I want to modify one point here, that is delta G system is equal to delta H system minus T delta system. That means I am going to derive the statement for a given reaction. I am going to derive the statement for a given reaction. Here, there that reaction is system for us. There that reaction is system for us. What is system? Anything which is under observation is called what? System. So that I put system here. That only difference here. We know that one point, that is what? Delta S total equal to delta S system plus delta S surroundings. Nothing but delta S universe equal to delta S system plus delta S surroundings. Let us assume this is 1, this is 2. We know one more formula, that is what? Delta S equal to delta H by T. This is seen already in entropy concept. Delta S equal to delta H by T. Next, one more point. Delta S surroundings equal to minus delta H system by T. Why? See, delta S equal to what? Delta H by T. Delta S system equal to delta H system by T. Similarly, delta S surroundings is equal to delta H surroundings by T. If you put system, here also system will come. If you put surroundings, here also surroundings will come. Suppose I want a system into surroundings or surroundings into system, then what happens? Sign will change. Delta H system is equal to minus delta S surroundings by T. Or we can write delta H is surroundings equal to minus delta S surroundings equal to minus delta H surrounding minus delta H system by T. So what you have to learn, if a system is converted into surroundings, then negative sign will come, or if your surroundings converted into system, then also negative sign will come. Now I want one expression, that is what? Delta S surroundings equal to minus delta H by T system. This is expression which relates surroundings and system. Here we are converting surroundings into system, so that negative sign has come. From equation 2, delta S total equal to delta S system plus delta S surroundings. If you put this surroundings value, this delta S surroundings value in this equation, then we get this equation. Then it can be written as, if you common negative sign in this equation, then we get a delta H system minus T delta S system. Then finally this delta H system minus T delta S system will be equal to what? Delta G system, because already we have seen here delta G system equal to delta H system minus T delta S system. If you substitute this value in this equation, finally we get T delta S total equal to minus T delta G system. Delta G system is equal to minus T delta S total. For all spontaneous process, delta S total is equal to positive. We have seen this point in entropy concept in previous video. Therefore, if you substitute this value in this expression, then delta G system is equal to what? Negative into positive? Negative. This means what? This means what? For all spontaneous reactions, delta G system is negative. That means by using delta G value, we can say that whether the reaction is spontaneous or not. How? If delta G value is negative for that reaction, that will be spontaneous. For all non-spontaneous process, delta S total is equal to negative. If you substitute this value in this equation, negative into negative, positive. So delta G system is equal to positive. That means for all non-spontaneous process, delta G system is positive. That means we can say that whether the reaction is spontaneous or not. Suppose if it is non-spontaneous, then delta G should be positive. For all equilibrium process, delta S total is 0. For automatically delta G system will be 0. So what is the point here? By using delta G value, we can say that whether the reaction is spontaneous or non-spontaneous or equilibrium. That is all about criteria for spontaneity. Here some more points are there. That is, delta G is what? Delta H minus D delta S. Suppose if both are negative values, both means delta H value and delta S value, both are negative values. Negative into negative, positive. Positive plus negative, either positive value or negative value. Then when delta G will be negative and or when delta G will be positive, if temperature is low, then delta G will be negative. If temperature will be high, then delta G will be positive. I repeat this point, listen carefully. If suppose delta H and delta S both are negative values, negative into negative, positive, positive plus negative, either positive or negative, then when delta G will be negative and when delta G will be positive. If suppose temperature is low, then delta G will be negative. If temperature is high, then delta G will be positive. See, if delta G will be negative, that is what? Spontaneous. So what is the condition? Spontaneous at low temperature, non-spontaneous at high temperature. I hope you understand about these 2 points. Next one, if suppose delta H is negative and delta S is positive. Delta H is negative, delta S is positive. This is negative value, this is positive value. Positive into negative, negative. Negative plus negative, we get negative value. So delta G will be negative absolutely at all temperatures. Suppose if it is positive value, that means delta H is positive and delta S is negative. Positive minus of minus, that means minus into minus plus. Positive plus positive, always positive value. Then delta G will be positive at all temperatures. That will be non-spontaneous. See, this is the fourth one, non-spontaneous at all temperatures. Now I hope you understand it very well. Last conditions, if suppose both are positive values, this is positive value, this is positive value, negative into positive, negative plus positive, either positive or negative, then when delta G will be negative and when delta G will be positive. Suppose when temperature is low, then delta G will be positive, that is non-spontaneous at low temperature. When temperature will be high, then delta G will be negative, that is spontaneous at high temperature. This is very important point.